Let's solve a problem about particle motion where we need to prove some interesting relationships between distance, velocity, and acceleration. Here's our question. If a particle moves such that its distance is directly proportional to the square of time, prove that its velocity is directly proportional to time and its acceleration is constant. Let's start by visualizing what this means. If distance is proportional to time squared, it forms a parabolic curve. Let's follow a point moving along this curve. Let's write this mathematically. Since distance is proportional to time squared, we can write s equals k times t squared, where k is some constant of proportionality. Now, to find velocity, we need to differentiate distance with respect to time. Using the power rule, we get v equals 2kt. This means velocity forms a straight line when plotted against time. As time increases, velocity increases proportionally. Finally, to find acceleration, we differentiate velocity with respect to time. When we differentiate 2kt, we get it equals 2k, which is a constant. Let's summarize what we've proven. First, if distance is proportional to time squared, then velocity must be proportional to time. And if velocity is proportional to time, then acceleration must be constant. This completes our proof.